Give you about another minute. See some furious button pushing still. Good? Okay. As we said before, you got options. If I'm going to do the law of cosines, which I have to do to start, I can do that from any one of these angles. Which one would be the most prudent? Okay. The angle that is most likely to be obtuse, if it is obtuse, is B. And since arc cosine finds obtuse angles, I'm going to find B first. That way, I can switch to law of sines for both of the other ones if I want to. So, measure of angle B is, you can write out the whole formula and solve and rearrange, or you can shortcut arc cosine of 24.3 squared minus 19 squared minus 21.8 squared, all over negative 2 by 19 by negative 21.8. Getting about how much? 72.743 degrees. Confirm? Lots of bobbleheads. Okay. So if I know that's the biggest angle, and I found out that it was an acute angle, that means I don't have to worry. I know that the other two angles can't be obtuse. So I can now switch to law of sines or law of cosines for the other ones. I can law of sines this guy now that I have a control pair. Say measure of angle C is arc sine of 21.8 sine of 72.4743 over 24.3. I can do it that way. I can do law of cosines again, probably the safest one. Measure of angle C is arc cosine of, and you just swap which one is which. This is the pair you're looking at now. So that goes in your A spot. Those go in your B and C spots. 21.8 squared minus 19 squared minus 24.3 squared over negative 2 by 19 by 24.3. Okay, whatever you're doing, whatever your jam is, what do we get for C? Yay, nay? Within a thousandth or so, depending on whether you're rounding, whether you're highlighting, whether you're using the answer feature. And the other one, I would just subtract from 180. Say 180 minus that, and I'll get measure of angle A is about ish. So here's what I'm looking for. Because you could have started from any one of the angles and then proceeded to any one of the remaining angles. What I'm going to say is whatever your first angle was, 1 for showing the formula setup, 1 for getting the correct angle. Whatever your second angle was, 1 for showing the formula setup, 1 for getting the correct angle, whether you did law of sines or cosines. And then angle 3 you just subtracted from 180, so I'm just going to say, did you get it? Okay? And that's how I'll grade that one on the test too. Okay? Anything about it? We're putting, we are plugging correctly before chugging. All right. Homework. Thirty-three. BCD is thing. If you need to just draw arbitrary triangle, BCD, like that. Angle B is 16. Little c is 27. Little d is 3. This is probably not drawn to scale. Being such an itty-bitty little 16, I bet there's an obtuse angle in there. So now what? Who do I have to find first? Okay. DC, I'll remember your geometry notation. I can call it little b because it's the side across from angle B, or it's the segment CD. And for that one, I just one-shot. Womp. The square root of 3 squared plus 27 squared minus 2 by 3 by 27 by the cosine of 16. Jam it in, do the thing. Square root of 3 squared plus 27 squared minus 2, no doodaloo. 327 cosine of 16. 24 and change. Once I've got 24 and change, oh, well, crap. Now we go find angles. Which one should I find first, though?
You can find
I want to find D because it's smaller if I'm using law of sines. But if I'm going to law of cosines, I don't care. In fact, if I was doing law of cosines, I would probably want to find C first because I know it's going to be biggest. Your choice. So if I do the law of cosines from C, I like that a lot better. Then arc cosine of whatever is directly across from it. Oh, let's back up. Make a fraction first. There we go. Gather. 27 squared minus 3 squared minus answer squared. I like that answer button. Over negative 2 by 3 by answer. Okay, so it's plugging that 24 and change in for me. 162-ish. Plus the 16 I already got. 180 minus that for my third angle. bitty living space. So two very, very, very small angles. And big mamma jamma. Okay? But the decision process is what matters here. Do I have a control pair? No. Okay, I have to do law of cosines. If I have a control pair, do law of sines. Once I have that side, now there's a control pair, I can do what I feel like. I can do law of sines, go find the smallest one first. Or I can do law of cosines, go find the biggest one first. Okay? It's kind of a little decision tree. Anything else from homework? Was the triple triangle Heron's one a little too annoying?
Yeah.
Sorry. Not hard, just annoying. Okay. All right then. Fair warning for tomorrow. There are now 2 appointments tomorrow morning, so y'all on your computer. Because all my stuff is online, you might be in here with a sub. You might be out in the commons on your laptop. I don't know. I will be back in the afternoon, but for the morning classes, you're going to be on your own. Uh-huh. 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 All right. Starting with 4-6 was all about our arc functions. I know a couple of you took me up on that offer and made this instead, naming these as your negative angles. Because here and here we have sine and tangent. I should say arc tangent, arc sine. But here and here I have arc cosine. Arc functions are restricted. Regular functions aren't. So it's just a matter of writing out each piece. Notice the directions. It does say, show each stage of the evaluation. Meaning, don't just write answer next to this. Write arc sine of what? Write cosecant of what? Write tangent of what? Okay? So, cosine of pi over 6 is what? Square root of 3 over 2. Just look it up on your circle. Arc sine, restricted to what 2 quadrants? So only look in quadrants 1 and 4 for who has a sine value of square root of 3 over 2, and it's at pi over 3. Arc cosine of -1, what quadrants is arc cosine restricted to? 1 and 2. So I look in quadrant 2, because it's negative, for a value of -1, and I get pi. So now go find the cosecant of pi. Remember, cosecant's reciprocal of who? Sine. So go find the sine value and flip it. What's the sine value at pi? 0. So when I flip it, undefined. Remember, x-intercepts become asymptotes. Everything explodes outwards. Okay, arc cosine negative root of 3 over 2. Arc cosine, again, quadrants 1 and 2. Look in quadrants 1 and 2 for a negative root of 3 over 2 and get and then go find the tangent of 5 pi over 6. Okay. Now, I'm just realizing as I'm looking at this, 2 of them were arc function first, then regular. 1 of them was regular, then arc. Remember, you should be able to go both ways. What if I said arc tangent of words -1, and then go find the secant of that? Versus if I said find the arc tangent of, and then I said the cosine of 11 pi over 6. Okay? You should be able to do it both ways, right? You just got to remember arc functions are the restricted ones. Oh, arctangent -1 is tangent quadrant 4. That's at negative pi over 4. Go find the secant of negative pi over 4, which is the reciprocal of square root of 2 over 2, so square root of 2. Because 2 root of 2, or 2 root of 2 over 2 will cancel after you rationalize and all that. Cosine of 11 pi over 6 is square root of 3 over 2. Where is the arctangent square root of 3 over 2? The arctangent is never square root of 3 over 2. So it's not one of my special triangles. I would just have to dump it in my calculator and find the angle that goes with it. Yeah.
So for the secant with negative pi over 2,
negative pi over 4.
How would it be negative pi over 4?
Arctangent of -1.
Which is negative pi over 2.
No. Arctangents quadrants 1 and 4, where x and y are the same. Okay. So it's stuff we've been in for 3 weeks. It's just now you have all the tools to mix and match. Okay. Label your vertical and horizontal axes however you feel like. It's just a blank grid. Arctangent graphs look like this. They've got asymptotes. They have a middle, middle. Okay, that's what a normal arctangent graph looks like. You modify the axes, just like we did with all of our other stuff, to make it fit this. So, what does that do? We always do the reciprocal of our b value, because if I cut your input, your income, in 1/5, it takes 5 times longer to get where you're going. So instead of these being 1 and -1, they're going to be 5 and -5. It's always the reciprocal at the b value. Bass-Ackwards land. +1. So normally, these are at pi over 2, 0, and negative pi over 2. Normally. If I'm moving all of those up 1, I just add 1 to all of them. So I could literally just say 1 plus 1. 1 plus this. Ta-da!
Do we need, like, between -5 and 5?
Oh,
Is that
okay. If you have had this, you had the extremes and the middle. You have the extremes and what should be in the middle of that? 0. Because is it possible that I have a horizontal shift? Yeah. Like what happens if I took this same thing and just threw parentheses on there? Well, now I don't have b separated from x minus h. I would have to turn that into 1/5 and then x plus 5, like this. Remember factoring those out? We did that way back in like section 1.
So would it be
So it's still a horizontal stretch of 5, because b is reciprocal, bass-backwards land. And instead of, now it says plus 5, I actually go minus 5. So I'd have -5, -10, 0. Okay? So all of our transformation stuff that you've been doing from algebra 2 all the way through this, still valid. Okay? But remember, whenever we had any form of a function, we had to separate our b from that. Every single kind of function that we've ever seen, you're supposed to separate that. Again, different forms of the test. This was arctangent. What happens if you get arcsine? Arccosine. Do you know what those parent functions look like? Do you got the notes in front of you with those parent functions? Okay. Notice the directions on 3 and 4 both say solve for the triangle parenthesis S. Because, who knows? You got to figure it out. So draw arbitrary triangle. Throw A on there. Little a. If I have C is 24, I'm going to put it here just in case it's one of those, angle, side, side triangles. It's an angle, side, side triangle. And it's acute angle. We're in trouble. There's either no triangle at all, a right triangle, and I have to treat it accordingly, or two triangles. Do I have a control pair to start law of sines? Yep. So I'll go find the measure of angle C is, if you want to set up, sine of 45 over 18 is sine of C over 24, cross multiply divide, arc sine of, or the calculator shortcut is going to be 24 sine of 45 over 18. So, what happens? Do I get 90? Do I get acute? Do I get obtuse? Do I get nothing?
So you get acute, get 75,
So what's that mean?
that means
There's another one possible. If I start with acute angle side side and I get acute, that means I have to look for another. So we're also going to have its evil twin over here, 180 minus that answer. And we're going to have doppelganger. Here he is. Where we've got A, C, B, still 18, still 24, still 45. But now I subtract 180 minus 70 and change, getting 109.471. I don't want to. Hey? Yeah? I have it on my planner for my prep today. Well, a lot of life has happened. Yep. All right. 180 minus stuff is what? 109 point things. Things. 471. Question mark. No one's vocalizing. Okay. When you have those two angles, now you subtract from 180 on both triangles to find your angle B's. 45 and 70, 115 and change, leaving measure angle B is 180 minus A plus that answer. Measure of angle B is 180 minus A plus that second answer. What we got? 0, 75, 115, 60, 64, 471?
Yeah, for measure. And then for the second ankle B, I got 25, 25, 21.
Okay. Finish it off. I have all three angles. I have two sides. For both of them, I'm going to need to do my law of sines to find the missing part. I suppose if you want, now that you know it, you do have side angle side. You could do law of cosines to find it instead. Square root of 24 squared plus 18 squared minus 2 by 24 by 18 times cosine of answer. I could go to law of cosines now. I've got the information. Or law of sine says sine of 45 over 18 is sine of 64 and change over thing. Cross multiply, and 18 sine of that 64, 471 over 24. No, sine of 45. There we go. Versus over here, it's 18 sine of little guy, 25, 529.
For the first little C, I got 22.071. And for the second little B, I got 10.372.
Someone else confirm?
I got the same for the first one.
Okay. Again, you don't have to highlight in your calculator. You don't have to use the answer button. If you just cut them off to 3 decimal places and use that number, you are going to be within a couple thousandths. It'll be really close, and that's okay. That's why that rule is in place in my classes, is specifically because of doing trig stuff back in geometry with kids who couldn't do the expression. Okay, there's a lot more going on with this. Either 3 or 4 will be a double triangle. We spent the whole day on it. It's going to be on your test. There's a lot more going on here too, so that means it's going to be worth more. Because when you look at the back, I got a review problem on there, and after I timed it out, the review problem puts it too big. So on your test, I'm going to have you just cross this one out, and if you have time, have fun. If you don't, don't. Don't start with that one. Do the other stuff first. Okay? But it is good to review it because today's a Thursday. 4 weeks from today, you are done with this class after taking 2 finals.
If we do that problem,
Well, y'all haven't decided yet. Okay? Oh, and hey, you're not getting open notes regardless because kids are rearranging their finals. I'm not going to have you do open notes unless you hand me every single shred of paper you came in to do section 1 with. You do not have notes next to final, even though there's 24 different forms of it, and then leave the room with those notes. Get what I'm saying? So, it's holy sheet and everything that you can write on it, or the review and everything you can write on it. Your choice.
is the review similar to like
I freaking identical different numbers. Just like this is. That's how I do everything. You should never be surprised by stuff in my class. I've got 40, 14, 29. A, B, C. Solve triangle. What do I have to start with?
you could do 40 because it's the
I've
big.
okay, law of cosines, and then I get to choose, right? If I'm doing the law of cosines, it is most prudent to choose the biggest one. So I'm going to start with the measure of angle B is calculator shortcut. Arc cosine of 40 squared minus 14 squared minus 29 squared all over negative 2 by 14 by 29. What do you think?
I got about 133.
There's one vote.
Yes.
Okay, cool. Um, let's say, for example, that you are just, it is so ingrained in you, find A first. You found A first. What should you find after that? Depends whether you use law of sines or cosines, right? If you're using law of cosines, find the bigger one. If you're using law of sines, find the smaller one. If I found A first, I would then find C by law of sines so that I could subtract from 180 to get the obtuse angle. Because if I did the law of sines after that to find B, I'm not getting 133 and change. I'm getting its reference angle of 46.2-ish. Okay? And that's going to throw the whole triangle out of whack. So just remember, law of cosines for the big angles, law of sines for the small angles. Okay? So now I do have a choice. What do you want to do? Law of sines or law of cosines? Okay? Law of cosines doesn't lie. So it's usually pretty safe. I could do A, arc cosine of 29 squared minus 14 squared minus 40 squared all over negative 2 by 14 by 40. Or I could have done arcsine, now that I know stuff. Arcsine of 29 sine of that 133-ish over 40. 496, you said? Okay. So again, you have to have the formula shown and the answer for two of the angles. And then for the third angle, I would just subtract from 180. That's 164, 165 and change. So 24 point meh.
I got 14. Yeah, I got 14.608.
That's true. 14 point who what? Okay. But again, I'm asking, or I'm checking, I am again asking you to show me a formula, show me an answer. Show me a formula, show me an answer. Subtract from 180 to get answer. Okay. Below that, find the area of this triangle in two different ways. So Heron's formula, I've already got that. S is 1/2 of 29 plus 40 plus 14. 54, 74, 85, 83. 83 halves? I like 41.5. That works. It's terminating decimal. And then the area is square root of that S times the difference from that S to each of my side lengths. 41.5 minus 29, 41.5 minus 40, and 41.5 minus 14. Now, the nice part about this is you're supposed to be finding it two different ways. Well, they should be the same, right? I hope. Round two, well, you just found all the angles. So you can do, the area is 1/2 29 by 40 by sine of whatever was between them, angle C. You could do 1/2 by 40 by 14 by sine of A. You could do 1/2 by 29 by 14 by sine of B, using the A, B, and C from above. Okay? So any one of those would work for your other method. No, you cannot just do this twice as your two ways. I suppose I should specify using two different methods. Okay? But it's different. No. And then we are getting close to the final, so I do want to review. How much was it, by the way? 146 and change? Okay. That final is looming. So even though I'm not going to make you do it on the test part, we should have time. 520 by 8. Because I think I told y'all I found out that you're not slow. I got faster. All semester I've been wondering why you're so slow. compared to every other class I've had for 14 years. I started my ADHD meds. You're not slower, I'm faster. And I have the data to prove it. You didn't get 33% slower, I got 25% faster. So now I have to take your stuff times 8. So 520, 840, 160. Yeah, that's like 43 minutes. No, we ain't gonna do it with this one. You'll still cross this out, but I still want to review it. Okay? I still want to review it. What do you think? Section 2.5. Factor, factor, friggin' factor. Whenever I see a rational expression, I better factor. Okay? So x plus 5, x minus 2. Okay? Do you remember what all the parts of the rational function do to the graph? Okay? Zeros of the numerator get me x-intercepts. So -5 and 2. So I'm going to go over here. 1, 2, 3, 4, 5. 1, 2. How would I find y-intercepts? Plug in 0, right? I always find my y-intercepts by finding the function of 0. Well, if I put in 0, those 3 disappear. I get 10, which means this is a big graph. I'm going to have to change my scale. Okay. I'll start by at least putting times 2. I might have to change it later. 2, 4, 6, 8, 10. Okay, what about asymptotes?
Isn't that when you can cross numbers?
If I cross out a set of factors, that's a whole at that 0. Okay, nothing canceled out here, so that means I'm going to have, where's my vertical asymptote?
That's at the bottom. Right?
Zeros of the denominator. So vertical asymptote at x equals 1/4. So right here. What about my horizontal asymptote? Depends on the degree, doesn't it? Do you remember the rules? Okay. The rules state if I have f of x is a x to the, do they do m over n or n over m? N over m, right? Alphabetical order. Very mathematical notation there. So if n is less than m, if the degree of the numerator is less, then y equals 0 is going to be my horizontal asymptote. Now that happens because if I tried to take this function divided by that function, it goes in 0 times. If n equals m, what happens when I try to take 5x to the third divided by 2x to the third? You get 5 halves. So I'm constantly doing that dividing thing, and that's why when they're the same, I get y equals, that's the leading coefficients. But in this case, n is greater than m. So there is no horizontal asymptote. I have to divide to find my oblique asymptote. I have to divide to find the oblique asymptote. And I included this particular type of problem because it also forces us to review our division. Do you want to do long division or synthetic division? Can I do synthetic? I am dividing by a linear factor, so it's okay. So you got your rules, and your rules say 1, 3, negative 10, divided by 1/4. 1 times a fourth is, well, 1/4. 3 plus a fourth, or 12/4 plus a fourth, is 13/4. 1/4 times 13/4 is 13/16. So negative 160/16 plus 13/16 is negative 147/16. We remember this trick. If I divided this by 4 to make my 0, I have to divide these by 4 to get my full division. So y is 1/4 x plus 13/16. Ew. I have to divide those by 4 as well. Now the remainder doesn't matter, remember? I have to get a remainder. Otherwise, if there was no remainder, then they would have been factors, then I would have canceled them. So 1/4 x plus about 1. So from there, up 1 over 4. 1, 2, 3, 4. Up 1 over 4. Up 1 over 4. Up. Oh, that's not 4. Don't both go with it. I don't know how Frank decides what things he's going to group together. Up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4. Down 1, back 1, 2, 3, 4. 1, down 1, 2, 3, 4. Remember, I'm going by twos. Ew. And then connect the dots. It's ugly. Which is why I cut this one out for actual test time. Okay? But I do want to review the concepts because, like I said, 4 weeks. Okay? 4 weeks yesterday, you start your finals. They are not that far away, so we need to start thinking about our review. Which also reminds me, the review for the final, I will give to you well before reviewing time, because I expect that you would actually go through it and start reviewing before that 1 day of review. Probably not a good idea to just use 1 day to review a semester of information. Okay? Especially if you get to write whatever you want on it. So, scramble yourselves up.